Hi students, this is Mr. Yao. Today we're going to talk about 2.1, where we will mostly review how to solve and graph inequalities. First, when we graph inequalities, we are going to have to draw some circles. And if we have this less than or greater than sign, we're going to use open circle, or as I refer to it, we are going to use a donut. And we do have these equal sign, which means we have less than or equal to and greater than or equal to. We're going to use a closed circle, or as I refer to it, a dot. We typically keep the variables on the left side so that the arrow points to the same direction as the inequality sign. So this is going to help us to just become intuitive and be consistent with how to graph. So for example, we have this sign. Well, that's just the arrowhead, so it's going to point to the left. If we have that, that's the arrowhead, it's going to point to the right. Same thing with these two. If we have the equal sign, that's pointing to the left. Equal sign, that's pointing to the right. Now let's have a look at some examples. First, x is greater than 5. So we have a number line that has some marks on there. We just need to label where 5 is and one number less and one number more. So in this case, it's pointing to the right because that's the arrowhead. And since it doesn't have the equal sign, we're going to put a donut right there. Number 2. This time the variable is not on the left side, so we do need to move p to the left side and keep -8 on the right side. However, when we move the variable to the left side, we do also need to flip the sign. So in this case, -8, and it's going to be a solid dot because we do have an equal sign and it's pointing to the left. One thing I do want you to be careful with, since we're drawing a number line, the more left, the more negative. So -9 is actually here and -7 is on the right side, not the other way around. Number 3 and 4, we're writing inequalities this time. So you see the number is -2. So x and -2 is pointing to the right, so it's going to be a greater than sign. And since it's a dot, we're going to have an equal. So x is greater than or equal to -2. Number 4, number is 2. We're still going to use x pointing to the left, so it's going to be less than. And in this case, it is a donut, so it is less than. X is less than 2. Unlike equations, instead of getting one answer, we actually get a range of answers. So like x is greater than 2, that means 3, 4, 5, 6, any of these numbers would work, or even bigger. So that's one difference compared to equations. Now, how do we solve inequalities? We solve inequalities just like we solve equations. In order to keep the inequality true, when you multiply or divide both sides by a negative number, we need to flip the sign. So that's the most important thing about inequality. And that's also the second difference compared to equations. First, again, is we got more than just one or two answers. It's going to be a range. And 2 is when we multiply or divide both sides by a negative number, we have to flip the inequality sign. Now let's have a look at some examples. First one, since it's -4 times x, we're going to divide both sides by a -4. And since we are dividing by a negative number, we need to flip the sign the other way. X is less than or equal to -2. -2, -3, -1. Since it has an equal sign, so solid dot, and it's going to be pointing to the left. That's example 1. Example 2, adding 10 on both sides. So we got -6 is greater than x, but our x is on the right side, so we're going to move it to the left side. X and -6 on the right side, but we do need to flip the sign. So x is less than -6. Since it doesn't have equal sign, it's going to be a donut pointing to the left. That's example 2. Number 3, I want you to pause here and try it for yourself first. Now that you have tried it, if you chose to subtract from first, that's totally fine. You're going to get r over -10 is less than 1. Then times both sides by -10. And again, since we're multiplying by a negative, since we're multiplying by a negative, we need to actually flip the sign so that we would get greater than -10. So that's one way to do it. Here's a second way. Notice that you have to subtract 4. You can also multiply by negative 10 in the first step. However, you do need to make sure when you multiply by negative 10, it is being multiplied on every single thing, including this 4. This is something you might actually have missed. Okay, so that's going to give us negative 10 cancel, so r minus 40 is greater than negative 50. At 40 on both sides, r is greater than negative 10. Either way, negative 10, negative 11, negative 9, since it doesn't have equal sign, it's going to be an open circle, a donut, pointing to the right. That's example 3. Number 4, subtract 5 on both sides. That's going to give us negative 6 is less than or equal to negative 4m. Then we're going to divide both sides by the negative 4. And since I am dividing by a negative number, that means I need to flip the sign. So m is on the right side, and that is going to be 3 halves on the left side. However, before we want to graph, we do need to flip the m to the left side so that it's consistent with the graph. So m is less than or equal to 3 halves. That's our 2. That's our 1. 3 halves is in the middle. And since it does have a solid point, it doesn't have equal sign, so we draw a solid point pointing to the left. One thing is, we typically draw the marks with whole numbers. That's why the 3 halves is going to be in the middle of 2 marks. Okay, number 5. Minus 35 on both sides. Got negative 15 is greater than negative 5s, divided by negative 5 on both sides. And again, we are dividing by a negative number. So we need to flip the sign, s on the right, 3 on the left. But since our variable is on the right side, we need to flip it to the left side, so s is greater than 3. So 2, 3, 4, a donut pointing to the right. Next, we need to get rid of the 2 first, so multiply both sides by a 2. We're going to get negative 2n plus 5 is greater than 6. Minus 5, minus 5. Negative 2n is greater than 1. Now we're going to divide both sides by the negative 2. Again, we're dividing by a negative, so we need to flip the sign. N is less than negative 1 half. So 0, negative 1, negative 1 half is in the middle. Doesn't have any equal sign, so it's a donut pointing to the left. That's number 6. Next, number 7. This is getting a bit more complicated. So first, we saw the parentheses. We are going to need to distribute first. Left side, we can combine like terms. So negative 18x plus 4 is greater than or equal to negative 20x. Negative 10 times negative 1 is a positive 10. We're going to add 20x on both sides. So we got 2x plus 4 is greater than or equal to, that is gone, 10. Minus 4 on both sides, 2x is greater than or equal to 6, divide both sides by a 2, x is greater than or equal to a 3. So if you chose to, instead of add 20x, you chose to add 18x, that's totally fine too. But you're going to get a negative 2x on the right side, so you need to actually flip the sign when you divide both sides by the negative 2, and also flip the sign because your variable is currently on the right side. That should also make you switch the sign twice, so you should still get x is greater than or equal to a 3. 2, 3, 4, solid dot, pointing to the right. Number 8. This is a more complicated question because we have a fraction on the bottom. We have fraction on both sides and we have denominator on both sides. So first, we still see the parentheses, so we're going to distribute first. We're going to get 2x plus 2 over negative 5 less than or equal to 3x over 4. Next, since we have denominators on both sides, we are going to need to multiply by the common denominator on both sides. So again, this time we're not finding the common denominator. We're not trying to get the denominators into the common one. We're trying to get rid of them. So we're going to multiply both sides by the common denominator, which is negative 20 or negative 20 over 1. Then I am going to ignore the numerator because again, our goal, the reason we multiply by negative 20 is to get rid of the denominator. So that means I'm not touching anything in the numerator. I am just getting rid of the denominator. So negative 20 over, together that's negative 5, that's going to give us a 4. Doesn't change anything about the numerator, so we still keep the 2x plus 2. And the right side, same thing. I'm trying to get rid of the denominator. That's going to give me a negative 5. I still keep the 3x, but it's 3x times negative 5. That's going to give me 8x plus 8 less than or equal to negative 15x. So I can add 15x on both sides, but also subtract 8 on both sides. That's going to give me 23x is less than or equal to a negative 8. Then I divide both sides by 23. Final answer, x is less than or equal to negative 8 over 23, which is between 0 and negative 1. So let's say that's about it. Negative 8 over 23 does have an equal sign, so a solid dot pointing to the left. Again, we only, actually, I forgot one thing. The sign flipped because we multiply both sides by a negative number, so the sign actually flipped. And this is flipped. That's also flipped. It's actually going to be pointing to the right. So again, when we multiply or divide by a negative number on both sides, we are going to need to flip the sign. If we just multiply by a positive number, that doesn't change anything. Next, number 9. See parentheses, so we're going to distribute negative 2x minus 1, 9x plus 4 less than or equal to. We're going to add 2x on both sides. So we got 11x plus 4 is less than or equal to negative 1. So 11x is less than or equal to negative 5, since we subtract 4 on both sides. X is less than or equal to negative 5 over 11. And since we're just dividing by a positive number on both sides, we're not going to need to flip the sign. So 0 and negative 1, negative 5 over 11 is in the middle. Solid dot because we have an equal sign pointing to the left. Next, number 10. We are going to need to distribute again. That's negative 2u, negative sign, so it's going to become a plus 1, 2u minus 4 on the left side. So add 2u, we got 4u minus 4 is greater than 1. Add 4 on both sides. 4u is greater than 5. So u is greater than 5 over 4. That's going to be slightly more than 1, so 5 over 4. Doesn't have an equal sign, so it's a donut pointing to the right. And that is everything for 2.1 inequality. Thank you.